Hi, I'm Dr. Sarah Roberts and I'm an astronomer at Swansea University. And in this short video, I'm going to be introducing you to an exciting new project that we're running called Stardust Hunters. I'm going to be talking about the who, the what, the where, and the why of the project. And then most importantly, I'm going to be talking about the how of the project. How can you get involved with the Stardust Hunters? So, looking at who's involved in the project. The Stardust Hunters project is an outreach project that's funded by the Science and Technology Facilities Council, and they're the research council in the UK who fund, among other things, astronomy outreach projects. This project joins together all these amazing places and amazing people who work in these places. So at Swansea University, there's me as the astronomer in the College of Science, and then we also have some researchers in engineering who are experts at looking at very, very small objects. We've got Astro Cymru involved. So Astro Cymru is run by Emma Ride, and she runs workshops, science, technology, engineering and maths workshops, STEM workshops across South Wales and beyond. We've got the National Museum of Cardiff involved in the project, so Jana Horak, who's an expert of meteorites. We've got Paul Smith in the National Botanic Gardens of Wales, and they do a lot of STEM workshops for schools and a lot of outreach. And then we've also got Oriel Science, which is a science exhibition centre that's run by Professor Chris Alton of Swansea University, but the exhibition centre itself isn't at the university, it's actually in the city centre in Swansea, so definitely worth a visit next time you're in the Swansea city centre. So we started this project last year after being inspired by this man here. So this is John Larson. Now John Larson is not a scientist per se, but he's actually a jazz musician from Oslo in Norway. And he started the hunt for stardust, or micrometeorites as we call them. So let me tell you his story. It was about 10 or 11 years ago that John Larson was sitting in his garden in Oslo, beautiful summer's morning, and he decided that he wanted to have his breakfast outside. So he wiped down the white plastic table that he was going to use. He went inside, got his breakfast, which I believe was strawberries, put them on the table. And as he sat there, he noticed a little black dot appear on the table, and it wasn't there before. And he picked it up. He said it was sort of glittering in the sun. He picked it up and he thought, well, what is this? And where did this come from? So he started learning more and more about what this little speck of dust might be and where it had come from. And the more he learned, the more he realised that actually these little specks of dust, which come from space, can be everywhere. They can be on our clothes, they can be in our hair when we're walking about outside, they can be found in gardens and rooftops. Scientists did know about these specks, which we call micrometeorites, previously. In fact, the first hunt, or the first search for these was done in, I think it was the 1870s, on a boat where they dredged up part of the sea floor, and they found these micrometeorites there. So scientists knew that you could find these, but they were looking for them on the ocean floors or in Antarctica, so places where it was easy to find them. They said that trying to find these micrometeorites, or bits of stardust as we say, in urban places like towns and cities would be too difficult, even more difficult than trying to find a needle in a haystack. But John Larson was determined to prove them wrong, and prove them wrong he did. Fast forward to now, and John Larson has found more than 3,000 of these specks. So let's have a look at what they are and where they come from. So here's an image of some shooting stars. So it's a beautiful image taken of the night sky, and what we can see here, apart from the stars in the image, are streaks of light. And these streaks of light are what we call shooting stars. And if you're lucky enough to go outside on a clear night, you may be able to see a shooting star. Now here's an experiment for you. I'd like you all, as you're watching this, to put your hands together and to rub them. Okay? Press them harder together and rub them faster and faster. Okay, what do you notice? You should notice that your hands heat up. What's actually happening is because of friction, your two hands rubbing together heat up due to friction. Similar things happen when things pass through our atmosphere. Whatever passes through the atmosphere rubs against the gases in the atmosphere, to put it simply, and heats up, and so it starts to glow. Now, sometimes there are large chunks of rock or metal that come from space, and they come through our atmosphere. We might see them as a fireball, and if they land on the floor and we see big chunks of them, we call them meteorites. Sometimes things just burn up completely in the atmosphere and we see this as a shooting star, but sometimes little bits of dust come through our atmosphere. This burns up and we see it as a shooting star, but the little bits then land on the floor and they're tiny. I'll show you an image in a minute. And we call these, because of their size, micrometeorites. So here's what a micrometeorite looks like. You can see it on the tip of somebody's finger here, and you can see it's very, very small, so you can understand why it's so difficult to actually find. We need to have special microscopes to actually look at these in detail and to help analyse to see whether they've come from space or not. Now, I was lucky enough a few years ago to have a work experience student with me, and we went outside in the grounds of Swansea University and we went hunting for potential micrometeorites. And here's one that we found on the grounds. So you can see it on the magnet here. So I had a magnet inside a food bag and we just gently moved it across the floor and we picked up bits of metal and some of those potentially micrometeorites. When I took it inside into the lab and I used just a normal microscope, and actually I've done this experiment with a microscope that I bought from Amazon for £10, so you can do this at home. This is the image that we got. So we've got bits of stone or rock or debris around the outside, but the potential micrometeorite shows up as a spherical object under the microscope. And this isn't the best image that's taken because I literally had my phone over the microscope finder view there. If you have even better microscopes, so electron microscopes, these are the sorts of images that you can get. I'm sure you can agree these are very impressive. So this is what a micrometeorite, so a bit of space dust or rock or metal from space, looks like under an electron microscope. So what we would like to do with the Stardust Hunters project is get you as your pupils in school, if you're a teacher or if you're a student in primary school, then you can do this yourselves. What we'd like you to do is go hunting in your back gardens or your schoolyards for these objects. And then what we'd like to do is to have a look at these objects through a microscope and pick out the ones which are spherical and send them to us, and we will put them through special microscopes that we have at the university to see if they look anything like these, and also to analyse what they're made up of and see whether they're actually man-made objects, which is a possibility, or whether they've come from space. So where is it that we generally look for these objects? Well, the best place to look is actually on the rooftops of buildings. Now, I do not recommend that you do this because of health and safety, but this picture of John Larson here shows him up on the rooftop sweeping for potential micrometeorites. And this is because they come down with the rain from the sky, or they come down from the sky and they settle on rooftops, and then they're not generally disturbed. But you can find them on the floor. There's no reason why you couldn't find them there. They're just slightly harder to find because they can get mixed up with man-made objects. So why are these micrometeorites so interesting to scientists? Well, the reason is because they're thought to have come from some of the oldest matter that there is. So remnants of minerals that came from even before the planets formed. So on the left-hand image here, we've got a picture of the solar nebula. So our solar system, all our planets and our star, formed from a cloud of gas and dust early on, which collapsed down into a disk and started spinning. And you have the sun at the centre, and then gradually over time, the bits of dust sort of gather together to form the planets, and the gas forms the outer planets. But what you have then is the leftovers of the planets forming, and some of these leftovers are thought to be what make up some of the micrometeorites. Another reason why these micrometeorites are very interesting is because they come through different layers of our atmosphere. And as they come through the different layers of our atmosphere, the science inside them, the amount of oxygen inside them changes. And this changes depending on what the makeup or the composition of our atmosphere was at the time that they came through there. So we've got an image here of the Earth, and there's actually different layers of atmosphere above our Earth. It's not just the sky that we see. We've got the exosphere, where satellites are, the thermosphere, where you see the northern lights or the aurora borealis, if you're that lucky. The mesosphere, so that's where you see your shooting stars appear. You've got your stratosphere and you've got your troposphere. Okay, but what we're interested in, or what scientists are interested in, is how much oxygen the micrometeorites sort of gain as they come through the atmosphere, because that gives us a measurement of what the Earth's atmosphere was like at the time that the micrometeorite fell through there. And if it fell through there millions or tens of or hundreds of millions of years ago, it tells us what the atmosphere was like at that time and gives us an indication about climate change. So how can you get involved in this project? Well, with the Stardust Hunters project, what we're wanting you to do, as I've said, is to go out and try and find your own micrometeorites. And if you're part of the Stardust Hunters project here in South Wales, then what we will do is send out a toolkit with everything that you need to be able to do this. So the toolkit will consist of a magnet, it will have food bags in there, it will have sieves in there, and it will have a microscope in there. So the idea is that you go outside with your magnet and a food bag, you sweep it along the floor, you pick up any bits of metal, because these objects, similar to meteorites, micrometeorites are made up of rock and metal, or a mixture of the two. So if you're using a magnet, you can separate out the bits of metal from just the plain debris. What you can do then is then sieve it through, because these are really tiny objects, so we're only interested in very small objects, and then you have a look at it through the microscope and see which objects are spherical. Any that you find, you can then take an image of and send it to us at Swansea University, where we can do a quick view of it and see whether we think it's a potential micrometeorite. And then if we think that it's worth analysing, you can send it to us at the university, where we will put it through our special microscopes, and we will do an analysis of the chemistry of the object and take more detailed images of it to see whether it's come from space. So if you're interested in getting involved in the Stardust Hunters project, then please get in touch with me, s.g.roberts@swansea.ac.uk. Thanks.